Hello, Luke. Welcome to Lesson 80. So today we're going to be talking about operations with scientific notation. So you recall in a previous lesson we talked about scientific notation and how to write large numbers in scientific notation. Now we're going to actually look at how to multiply and divide numbers that are written in scientific notation. So let's give a couple examples here. I think the best way to do this is just to dive right into it. So let's say we have these two numbers and we're multiplying them by each other. So we have kind of this first set of parentheses multiplied by the second set. And if you look at it closely, and initially you might say, oh, they're both in scientific notation. But if you look at it closely, they're not actually in scientific notation. All right, look at these two numbers. Do you see why they're not in scientific notation? Hopefully you do. Remember that in order to write things in scientific notation, we always start at the beginning of the number and find the first digit that's not 0, reading from left to right. So if I read from left to right here, the first digit that's not a 0 is this 6. So to write it in scientific notation, I want this first number to look like 6.4. We want the decimal point to come right after the first non-zero digit. So here, the decimal point is clearly way earlier than that. So although this somewhat looks like it's in scientific form, it is not. We need to get that decimal in the right location. So same thing applies here. Where's the decimal in this number? Well, the decimal would be here, right? It's just invisible. The number is 2000. So again, where do we want it if we're putting it into scientific notation? We want it after the first non-zero digit, reading from the left to the right. So this is the first non-zero digit. So we want that decimal point immediately after the 2 in this case. So it'd be 2.0. Okay, that's what we would want. So seeing that, we should, recognize then that these are not in scientific notation. So the first step in all of these problems, whether it's multiplying, dividing, or doing a little bit of both, multiplying and dividing, of scientific notation numbers, we always want to first get them into scientific notation. That's the first step. All right, so don't worry about multiplying yet. Let's first write it in proper scientific notation form. All right, so let's do that right now. All right, so how do we do it? Well, we first put the decimal where we want to put it, 6.4. And then we have to ask ourselves, starting with this number, if we want to get back to our original number, how many decimal positions would I have to move that decimal point? So it's here now because we've placed it here. So to get it back to where we started, we'd have to move it once, twice, 3 times, 4 times to the left, right? That's the direction we'd have to go to get it back to where we started. So if you think left, we should always be thinking minus when we go left, right? And I should probably just make sure you understand this. Always go from where you want to be to where it is. Okay? I'm going to say that again. Go from where you want to where it is. So this is where we want it. We're going to start there, and we're going to go to where it is. And since we're going to the left, we're going to have a negative exponent for our 10 here, right? We're going to multiply this by a 10 to a negative exponent, 4 positions to the left, so it's going to be a negative 4. Okay? It's easy to confuse because sometimes you might try to do the opposite. You might try to start with where it is and move to where you want to go. And if you do that, you will say, oh, I'm starting here and I'm moving this direction 4 places to where I want to go. And you can see how that gets confusing because now you're moving this direction and we still need this negative to make it all work out, and we're actually going to the right. So I guess just bury that, or ingrain that in your mind that we're going to start from where we want the decimal point and then go back to where it began. Always start from where you want and then go to where you begin. Okay? All right, that way everything will work out. So we're moving to the left 4 times, so it's going to be a negative 4, but we still have this times 10 to the negative 3. So that's still here, times 10 to the negative 3. Okay, so that's the first set of parentheses. Now the second set, we have 2.0. We want that decimal point to be right here. Okay, so this is where we want it. Let's move to where it is. It's over here. We move it 3 places to the right this time. So we're going to multiply this by a 10 to a positive 3. And of course, we have this other 10 to the positive 3 here as well. All right. Okay, so once we're at to this point, now we can do a little simplifying. This is going to become 6.4 times, we can combine these 10s, 10 to the negative 4 times 10 to the negative 3 is going to be a 10 to the negative 7, right? Add the exponents. Same thing applies here. We have a 2, I'm just going to drop the 0 and the decimal point, they're not needed, times 10 to the 6th. Okay, now we have it in scientific notation. The decimal points are where we want them to be. This is in perfect scientific notation form. So now we get to the heart of the lesson today, which is how do we multiply these two things by each other? All right. Now, what you may be tempted to do is to think, oh, I see 2 sets of parentheses. I see a number here, a number here, a number here, a number here. Maybe I should try FOIL, right? Maybe I should multiply the first by the first and the outside by the outside and the inside and so on and so forth and FOIL this out. That would be a mistake. That would be a mistake. So do not do this. We are not using FOIL. Why are we not using FOIL here? Think about it. Why are we not using FOIL? Well, the answer is because there is no addition. Everything is being multiplied here. We have a 6.4 and it's being multiplied by a 10 to the negative 7. We have a 2 and it's being multiplied by 10 to the 6th. FOIL and distributive property in general only applies when we have some sort of addition going on. So if I have x plus 2 times an x plus 4, yes, this would require FOIL. Why? Because these are being added. They're not being multiplied. Here they're being multiplied. So very, very different, okay? Because this is being multiplied, we can arrange these in any order. This is also being multiplied. There's only multiplication being done in this whole expression. So remember, when we multiply things, we can rearrange the order. So if I have 2 times 3 times 4, I could do it like that, or I could rearrange the order and maybe do 4 times 3 times 2, or I could flip-flop these two and have 3 times 2 times 4. It doesn't matter what order I multiply these in, as long as I multiply everything. So the same thing applies here. I have all this multiplication being done. I can rearrange it in any order that I choose. Okay, and to make it simpler, I'm going to rearrange it so that I have kind of my numbers out in front, these numbers, the numbers that are not being raised to a power. Okay, we're going to place those out in front. So we're going to say 6.4. We're going to multiply that by a 2 first. And then we're going to multiply these by what's left over. We have all of our 10s. We're going to kind of group all of our 10s together at the end. So we have a 10 to the negative 7. And we have, that's being multiplied by 10 to the 6th. So all I did was just reorganize this, which I can do because everything is being multiplied. All right. So now, excuse me, I need to combine some terms here. So 6.4 times 2. Well, let's figure that out. 6.4 times 2 is 12.8. So we have 12.8 times 10 to the negative 7 times 10 to the 6th. That's just going to be 10 to the negative 1, right? So our answer in this case is going to be 12.8 times 10 to the negative 1. All right? So hopefully that makes sense. Again, just to recap here what we did, we started with a multiplication problem, and the first step was to rewrite it in proper scientific notation. That's always the first step. Write it in scientific notation. Once we have it in scientific notation, we can rearrange so that all our 10s are grouped at the end, and we can multiply the numbers out and multiply the 10s out. All right, and then rewrite it at the end. I should probably write this as this multiplication sign because that's the way we do it in scientific notation. Rewrite it as a scientific notation at the end in your solution. All right, excellent. So let's try another one here. Maybe go ahead and pause the video. Give this one a shot. Do it on your own and see how well you do, and then we'll do it together. All right, so the first step again is to write this in scientific notation. So where do I want the decimal point in this first part of the problem? Well, my first non-zero digit is the 3, so I want it right after that. So it's going to be right here that I want it. So I want it as 3.0, or just consider it, 3. Okay, now if I start at the point where I want and go back to where I began, I move it 3 places to the left. Left indicates negative, so we're going to multiply that by 10 to a negative 3, but then that's being multiplied by a 10 to the negative 4. So that's our first set of parentheses. The second one, where do we want the decimal point? Well, we want it right after the first non-zero digit, which would be right here, and actually that is where it is right now. This one is in scientific notation. They did that for us. Okay, that's correct. So we don't need to do anything here. It's just a rewrite. 2 times 10 to the 20th power. Okay, now we can do a little combining here. 10 to the negative 3 times 10 to the negative 4 is going to be 10 to the negative 7. So we'll write that as 10 to the negative 7. 2 times 10 to the 20th. All right, now we're going to rearrange, put all of our 10s at the end. So we have a 3 times a 2 times a 10 to the negative 7 times a 10 to the 20th. And if we multiply this out, this is going to give us 3 times 2 is 6. 10 to the negative 7 times 10 to the 20th, well, that is just times 10 to the 13th. And there we go. There is our solution. All right, excellent. Let's try another one. So if you didn't get the last one, you get a second try here. Pause the video, try this one on your own, and then we'll do it together. All right, so once again, where do we want the decimal points to put this into scientific notation? Well, we want the decimal point right here. Okay, so we want it as 4.0, which is just a 4. And if I work my way back to where I started, I'm working at 4 positions to the left. So that's going to be a 10 to the negative 4, 4 positions to the left. I'm just going to write that here. It's just 4 positions to the left, 10 to the negative 4. And then I'll just combine these two. So 10 to the negative 4 times 10 to the negative 5th is 10 to the negative 9th. I'm just combining a few steps here. I think we can do that. All right. And then over here, we have a big number. We want the decimal point right after the 8. That's the first non-zero digit. So that's where we want it. Where is it? Well, it's way down here. So to get back to that, we'd have to move it once, twice, 3 times, 4 times, 5 times. So we're going to have an 8.0, which is just an 8, times 10 to the positive 5, because we had to move it to the right to get back to where we started. Okay? All right. So if you didn't get this, make sure you understand what you did wrong in your work so that you don't make the same mistakes. Actually, this is probably the trickiest part right here. It's just writing it in scientific notation. All right, so now we do some grouping here. We're going to put the 4 times the 8, and then put all of our 10s at the end. 10 to the negative 9 times 10 to the 5th. All right, so 4 times 8 is 32. And then we're going to use this multiplication sign for the scientific notation part. 10 to the negative 9 times 10 to the 5th is going to be 10 to the negative 4th. And there we go. There it is. It's as simple as that. All right, now let's talk about division. How would we divide larger numbers or numbers that are in scientific notation? The process is essentially the same. The first step, again, is to write it in scientific notation. So let's look at the numerator here. So the numerator, we want that decimal point right after the first non-zero digit, which would be right here. So I want that to be a 1.6 in the numerator. Okay? And now we're going to multiply that by a 10. What power is that going to be to? Well, again, we start at where we want it, and we go back to where it is. It's 3 positions to the left. which means negative. So it's going to be to the negative 3. Okay? In the denominator, we want that decimal point right after the 4. So it's going to be a 4.0, which is just a 4, times a 10 raised to what power? Well, where is the decimal point here? It's over here, right? So to get to there, we need to move it 5 positions to the right. So we're going to multiply this by a positive, or excuse me, 10 to a positive 5 or 5th power. All right. Okay, now once we've got it in scientific notation like this, now we are going to essentially kind of do what we did earlier. Okay, we're going to just kind of divide this out. So we're going to write this as 1.6 over 4. We're just grouping again. So 1.6 over 4, we're just taking this first part here, grouping that together, and then recognizing that that can be multiplied by this second grouping of tens. So it would be 10 to the negative 3 over 10 to the 5th. Okay. Now, 1.6 divided by 4. You could certainly do that. If you divide that out, take the 1.6, divide it by 4, you'll actually find that that is equal to 0.4. All right. So 0.4 is, then multiply that by 10 to the negative 3 over 10 to the 5th. Now, if I move this 10 to the 5th upstairs, right, up to the numerator, it would become 10 to the negative 5th. And as such, I could combine it with 10 to the negative 3rd. So 10 to the negative 3rd and 10 to the negative 5th is going to be 10 to the negative 8th. Right? That way we're not writing it as a fraction. Now it's 10 to the negative 8th. Right? Now, is this our solution right here? Well, actually, not quite yet. Okay, why isn't it? Well, it's not because it's not in scientific notation yet. So how would I get this into scientific notation? Well, I need to look at the decimal point again. Where's the decimal point? It's not in the right spot, right? We want it right after the first non-zero digit. So that puts us right here. Do that in a different color. Whoops. Puts us right here. This is where we want it. But it's not there. It's before it. So we need to rewrite this in scientific notation. So we want it right here. So that would make it just 4.0, which is just 4. And we're going to multiply that by a 10 to what power? Well, to get back to where we started, we'd have to move it 1 position to the left, which means we're going to have to multiply this by a 10 to the negative 1. But that is also being multiplied by this 10 to the negative 8th. So combining the tens, we have 4 times 10 to the negative 9th. Okay, so watch out. Sometimes when you do these problems, especially division, you may end up with an answer that looks like it's in scientific notation, but it's not yet. You need to move that decimal point further. Okay, so always double check that decimal at the end to make sure it's in the right spot. All right, very good. That is how you do division. So now let's really throw some things at you here. Let's do a little bit of both. So here we have a problem where we have multiplication and division going on. How would we do this? Well, why don't you give it your best shot. There's really nothing new here. I'll tell you that up front. There aren't any strange tricks going on here. It's just what we've already been talking about. And go ahead and try it and see how you do. All right. So the first step, again, is to get everything in scientific notation. So where do we want this decimal point? After the 7. So that's going to become a 7.0, which is just a 7, times 10. Now, I moved, if I try to get back to where I started, I have to move it 4 places to the left, which is going to be a 10 to the negative 4, right? Which, if I combine with this 10 to the negative 23, is going to give me a 10 to the negative 27. All right, so there's my first factor there. And then I've got this second one. Where do I want the decimal? I want it here. Where is it? Well, it's here. So I want it to be 4.0, which is 4 times 10. And to get back to where I started, I'm moving it to the right 3 places. So that's going to be a 10 to the positive 3. If I combine that with this 10 to the positive 6, I end up with 10 to the positive 9. Okay. In the denominator, we have to do the same thing now. We want this decimal point here. So we're going to have a 4 times a 10. Now I moved it, I would have to move it 2, 4, 5 places to get it back to where it started. So it's going to be a -5 because I'm moving to the left. And then I have this other number. I want the decimal point right after the 7. Right now it is over here. So I would have to move this 6 places to the right. So it's going to be 7 times 10 to the 6th, right? And there we go. Now everything's in scientific notation. Now let's take the numerator and do some multiplication there by rearranging. So we're going to have 7 times 4 times 10 to the -27 times 10 to the 9th. In the denominator, if we do some rearranging, we're going to have 4 times 7 times 10 to the -5th times 10 to the 6th. All right. And then what we can kind of do is just break this division problem up into 2. We can say that, you know, it's kind of, let me change color here. We kind of have this section right here. And that section is being multiplied by this section right here, the 10 section. All right. So if we take this first section here, the number section, we have 7.7 times 4, which is 28, over 4 times 7, which is 28. Look at that. Isn't that nice? And then that's being multiplied by 10 to the -27 times 10 to the 9th is 10 to the, what, -18th? 10 to the -18th over 10 to the -5th times 10 to the 6th is just 10 to the 1. Okay? This can be further reduced. 28 over 28, we know that's a 1. Times, now again, we want to write this as 110, so we want to get rid of the fraction. So if we move this lower 10 up, it becomes 10 to the -1. Combine that with the -18, and you end up with 10 to the -19th. So there is our number. Now just check, is it in scientific notation? Yes, it is. The decimal's here, which is where we want it to be. All right, so the answer is 1 times 10 to the -19th. All right, very good. Let's try another one of those. This will be our last one, I believe. Yeah, this will be our last one. So this is your last try to get it right. If you haven't gotten it right already, go ahead and try it on a separate sheet of paper, and then we'll do it together. All right, so you should be pretty familiar with the process at this point. So we're putting it into scientific notation. So we want the decimal here, which would make it a 2 times a 10. We'd have to move it one place to the right to get it back to where we started. So this is going to be a 10 to the 1. And then we have to get it, combine that with the -45. It's going to be 10 to the -44, right? All right, then our next term, we want it to be just 4 times a 10, and I'd have to move it 2 places to the right, so it's to the right, so it's 10 squared, and a 10 squared multiplied by a 10 to the 20th is going to be 10 to the 22nd. In the denominator, same process here. We're going to have to put our decimal here. That's going to be a 1 times 10. And we'd have to move it 5 places to the right, so it's going to be 10 to the 5th times, put our decimal here, we're going to get an 8 times a 10. Now, I'd have to move it 3 places to the left, so it's going to be 10 to a -3 right here. And 10 to the -3 combined with 10 to the -15 is going to be a 10 to the -18, right? Okay, so we got it that far. Now we do some rearranging. For the numerator, we have a 2 times a 4. And then over here, maybe just we'll put our multiplication sign here. So we have 2 times the 4, and then over here I'm going to put all my 10s. So 2 times the 4, and then I have a 10 to the -4, and a 10 to the +22. Now I could do those in my head right now, but let's just maybe make it a little bit more clear. Times 10 to the 22nd. Again, all I'm doing is just splitting up my numbers 2 and 4, setting that on one side of the product here, and then on the other side putting all my 10s. Okay? And then in the denominator, same business. We have 1 times 8, and then we have a 10 to the 5th times a 10 to the negative 18th. Okay, now we just kind of do some work here. So, and I guess watch out. This is 2 times 4, and this is 1 times 8. It's not 1.8. So 2 times 4 is 8. 8 over 1 times 8, which is 8, it's just going to be 1, right? So once again, we end up with just 1, and I'm just going to change this sign to the other multiplication sign. And we have 10 to the negative 44 times 10 to the 22. Well, that's going to be 10 to the negative 22 over 10 to the 5th times 10 to the negative 18th, 10 to the negative 13th. All right, now last step here is we want to move this 10 to the negative 13th up. So it's going to be 10 to the positive 13th. So we're going to have 1 times a 10, positive 13, and negative 22 is going to be a negative 9, right? So we end up with 1 times 10 to the negative 9th. And there we go. All right, so there you have it. Again, it's not too complicated. It's fairly straightforward, and hopefully it's pretty clear. All right, so we will stop there, and I will see you tomorrow.